Okay. So the first one is angle-angle similarity postulate. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. It shows a picture here of two similar triangles. It shows that there's two angles that are matching. If two of the angles are matching, then the third one has to be matching as well because it would all add to 180. So if you see that two are matching, then all of them are matching, meaning that the triangles are similar. And then the next one, side-side-side similarity. Just like side-side-side congruence, side-side-side similarity, you take the corresponding sides, and if they're proportional, then you have similar triangles. So if the corresponding side lengths of two triangles are proportional, then the triangles are similar. So we'll do an example here too. So here you have two similar triangles. If you take corresponding sides, so this side corresponds with this one, and I'm going to take 24 and put it over 15, put it equal to, this side corresponds with this one, so 32 over 20. And this one corresponds with this one, you have 40 over 25. If all these ratios are the same, then you have similar triangles. If you were to simplify the fractions, or you could just divide this and get the decimal. If you divide this, you'll get 1.6. If you divide 32 divided by 20, you get 1.6. And 40 divided by 25 is 1.6. So since the scale factor is consistent, you have similar triangles. And the last one, side angle side similarity. If two consecutive sides of one triangle are proportional to two corresponding sides of another triangle, and the included angles are congruent, then the triangles are similar. And I'll show you what that means in the picture here. Okay, so when you look at the picture, you have side angle side, side angle side. Obviously the side lengths don't match, but what you're trying to determine is if they're proportional. So is this proportional to this in the same ratio that this side's proportional to this? Well, when you divide this out, 8 divided by 4 is 2, and 18 divided by 9 is 2. So therefore the scale factor is the same, and you have side angle side, side angle side similarity. Ready to move down to the examples? Okay, so now we're going to look at some examples. It wants us to to determine if the triangles are similar, and then write a similarity statement if they are similar. So the first one here, I noticed that we have two 90-degree angles, and we also have two 30-degree angles. So I have two angles that are matching, so therefore I have angle-angle similarity. So yes, they are similar. And then as far as the similarity statement, I can say that triangle ABC is similar to triangle ZYX. And when I named it, for the first one, I did the 30-degree angle, 90-degree, and then the one that wasn't labeled. And when I labeled this one, 30, 90, and then the one that wasn't labeled. And number 2, I see that all the side lengths are labeled, so I'm going to try to prove that these are similar by side, side, side. This side corresponds with this one, so I have 8 over 4. This side corresponds with this one, 10 over 5. And then the bottom corresponds with the bottom over here, 13 over 6. So if all these ratios are the same, I have side, side, side similarity. 8 divided by 4 is 2. 10 divided by 5 is 2. But then 13 divided by 6 is not 2. It comes out to like 2.166 repeating. So since the scale factor isn't consistent, these are not similar. Number three. Number three doesn't have any numbers, but it does have these little lines that mean all the sides are the same. So we have equilateral triangles. I'm just going to choose a random number, like maybe 4. So all these side lengths are 4. And then let's say all these side lengths are 3. So then I set it up the corresponding sides. 4 over 3 equals 4 over 3 equals 4 over 3. Well, those are all the same ratio, so I do have side, side, side similarity. And the next page. Okay, so we're going to repeat the same process. It wants to know if they're similar and why or how. So here I see that I have side angle side and side angle side. If my corresponding sides are proportional, then I'll know that I have side angle side similarity. So here's these two sides are corresponding, so 21 over 9. Is that equal to 42 over 18? When you divide this out in a calculator, you get 2.33 repeating. And if you're to divide this out, you get the same thing, 2.33 repeating. So therefore, since we get the same decimal, we have side angle side similarity. And then when you name the triangle, you have to make sure to go in the same order each time. Here they did FGH, starting with the 76-degree angle. So I'm going to do UVW. Number 5, I'm going to skip over it. There's just a lot of problems here, so I'm only going to do the ones that are really important or to show you a variety of different problems. Number 6. Number 6, it shows that these angles are congruent. We also know that vertical angles are congruent, so we have those angles that are the same measure too. So now we have two angles in each that are the same, so we must have angle-angle similarity. HGF and HTS. And the next one. Okay, the triangles are similar. They tell us that right away. Find the value of each variable. Okay, so we're going to find the value of A and B. Before I do that, I need to make sure that I know my corresponding parts. This corresponds with this one right here. This corresponds with this. You'll notice they're kind of flipped. And then this side corresponds with this one. Okay, and then I can set up the proportions. I'm going to do A over 12 equals 9 over 15. And then use cross multiplication. And then to find B, same thing. I'm going to do B over 10 equals 9 over 15. So when I'm setting this up, I'm doing the first triangle to the second one, B over 10, and then again first to second in the same order. And then cross multiplying. 15B equals 90, then B equals 6. Okay, the next example comes up like over and over again. I even remember this coming up on the SATs as well. It says a person 6 feet tall casts a 1.5 foot long shadow, and it shows it right here, which is nice. They give you a picture. At the same time that a flagpole casts a 7 foot tall shadow. How tall is the flagpole? So this is our x. Well, this corresponds to the height here, and then 1.5, the shadow corresponds with the shadow. So we're going to do 6 over x equals 1.5 over 7. And then we can use cross multiplication to solve. 1.5x equals 42. We get 28. Okay, so I'm going to consistently do like one triangle to the other like that, just to keep the process consistent. But you may notice that there's also proportionality here. So if I did 1.5 to 6, like 1.5 over 6, I could put that equal to 7 over x, and I would get the same answer with the cross multiplication. So this is proportional to this, in the same ratio, this is proportional to this. So I will continue doing it the same way with corresponding sides, but just know that sometimes you can use that as a shortcut. So you may have noticed that 1.5 times 4 is 6, so 7 times 4 would give you this height, and you can use it as a shortcut if needed. So do you want me to show you that again? So you can do 1.5 times 4 to get 6, and you can do 7 times 4 to get 28. So there's proportionality throughout these triangles, and each day it'll introduce a different way, but it doesn't mean you can't kind of use them already if you realize they're there. Okay, so here identify the similar triangles, then find each measure. So here, this corresponds with this here, and this side corresponds with this one. So I'll do 13 over x equals 10 over 20, and then use cross multiplication. Number 2 here, this is the one that people got stumped on Khan Academy last week. It is on Khan Academy again, and hopefully you'll know how to do it this time. So there's 2 similar triangles here. There's the inside one, and then there's the one on the outside. What I'm going to do is draw them separately up here. So here's the smaller one, and here's the larger one. So for the smaller one, the dimensions are 26 and 20. And then for the larger one, it says that this length is x. And then this length right here would be 26 plus 13. So 26 plus 13 would be 39. And then from there, we have this corresponds with this. So 20 over x equals, and then this corresponds with 39, so 26 over 39. And then just use cross multiplication. Okay, then we have a word problem here. This is the same shadow problem that I told you would come up again and again. In sunlight, a cactus casts a 9-foot shadow. It shows the cactus here. It says the cactus is x feet tall, and it casts a 9-foot shadow. At the same time, a person that is 6 feet tall casts a 4-foot shadow. Use similar triangles to find the height of the cactus. Well, 6 feet over x equals 4 feet over 9. And then cross multiplication, 4x equals 54, and then x equals 13.5 feet. Okay, we are going to turn to the next page. On the next 2 pages, I'm just going to pick and choose questions that I know you need to know for the homework. So when you see all those problems, don't be alarmed, we're not doing them all. Okay, so the first one we're going to do is number 1. Okay, first of all, I see vertical angles are congruent. They want us to state whether they're similar or not. So we have side angle side here. If we have side angle side proportionality, or if those sides are proportional, then we can say that they're similar. So this corresponds with this here, and this corresponds with this one. So 40 over 16, is that equal to 39 over 16? Right away, no, those aren't equivalent ratios, so no, not similar. Number 2. So now I'm going to take corresponding sides and try to prove side similarity. So this side corresponds with this one, so 84 over 14. Is that equal to 72 over 12? And is that equal to 48 over 8? If I get the same scale factor throughout, then it is similar. 84 divided by 14 is 6. 72 divided by 12 is 6. And 48 divided by 8 is 6. So since the scale factor is the same, they are similar by side similarity. And then to name the similar triangle, CBA is similar to FGH. Number 3, it shows that 2 angles are congruent, so therefore we have angle-angle similarity. Triangle JKL is similar to TUV. When I named the second triangle, I made sure to go in the same order. It was going from the 1 line to the 2 to no line, so 1 line, 2 line, no lines. Okay, so here, we're not going to do 4, 5, or 6 together. Those are there if you want some extra practice, if you're studying for the test or whatnot. We're also going to cross out 7 and 8, and then we're going to do number 9.
Wait, did you do 3?
Yes, there it is. Okay, so I crossed out everything, and then we're just going to jump down to number 9, because there are some on the homework like this. Okay, so first thing before we even get into the triangles, something you have to notice is that this line is showing that it's parallel to this line. And what that means is now you have some congruent angles. This would be a transversal, and alternate interior angles are congruent. So this is congruent to this angle here. And then with this transversal, this angle is congruent to this one. Okay, now we're going to look at corresponding parts. So this corresponds with this side right here, which is 4. So we have 16 over 4. And then this side corresponds with this length here. So we have 8x plus 18 over x minus 3. And then I'll use cross multiplication. 16 times x minus 3 equals 4 times x plus 18. I've already done the calculator work, so I'm just going to copy down the numbers. So that solves to x equals 10. The question asks for the length of JL right here. So if you were to plug in 10 for x, 10 plus 18 is 28. So the answer is 28. And then as far as naming the triangle, we have JKL. MNL would be the congruent triangle. Or similar triangle, sorry. Okay, on the next page, again, we're not doing it all. We're just doing, actually, I only have planned to do one problem on the back. Okay, so the problem that we're going to do is number 11. It's a triangle within a triangle. You have a smaller triangle right here, and then the larger triangle outlining it. So to find this length LM right here, I'm going to draw the two triangles. This is the smaller of the two. The smaller triangle has dimensions of x, 7.2, and 16. The larger triangle, the outer triangle, 8 plus 16 is 24, so this whole length is 24. And then this length right here is 9 plus x. And then they don't tell us this height right here. Okay, so looking at this, we have corresponding sides right here. This corresponds with this one. So I can do 16 over 24. And then this side corresponds with this one. So x over 9 plus x. And then I can use cross multiplication. And again, I already did the calculations before. This is 144 plus 16x. And it comes out to x equals 18. And then if you look up here, LM, which is what it's asking for, is just x, so LM is 18. And then KVM is equal to LPM. I do want to show you a shortcut on this one. Tomorrow we're going to learn that if these two lines are parallel, then these parts are proportional. So if these lines are parallel, then 8 is in the same proportion to 16 as 9 is to this number. So if you notice 8 times 2 is 16, you can double 9 to get 18, and that would be a much quicker, easier way to solve this problem. So just so you are aware of the shortcuts that are coming. But of course, this would always work as well. And that's it. That's all we're going to cover today. Of course, you have these extra problems if you want to do them for extra practice, but you don't have to. From here, the rest of class, you're going to get to work on homework 7-3.